Hello, good morning. My name is Kiran Kumar. I am from International School of Management Excellence. Today I am going to teach you how to compute the beta for the purpose of applying in the capital assets pricing model. Capital assets pricing model, as you must be knowing by now, is an asset pricing model that helps in determining the required rate of return. There are three inputs that are required to apply the model. The first one is the risk-free rate, which is defined as the rate that an investor can earn without taking any risk, and the market risk premium, which is the excess return that the investor expects for having invested in a market portfolio over and above the risk-free rate, and the beta value. Beta as a statistical parameter, it is the regression coefficient which helps in determining the amount of risk that the investor takes in investing in a particular security than investing in the market. To explain in a different framework, the beta value tells the sensitivity of individual securities price to that of the market. Now, statistically speaking, beta is the regression coefficient. Alright. Now, for regression coefficient, to compute the beta in that way, we need two variables. One is the dependent variable. In the case of beta computation, as we are trying to determine the sensitivity of the individual security, the security price becomes the dependent variable. At the same time, the independent variable, which would be the market index price. So now the challenge for us is to collect the data for both this. So we need to go to some website and try to collect the historical data of these two variables. As my purpose is to help the student community to download the data, I am also showing you how to download the data from one of the website called Yahoo Finance. Yeah, now that I have opened Google Chrome, I will directly go to google.com. And this is generally how I search for any data. Let us assume that we are trying to compute the beta for Reliance Industries. So I will try to type Reliance Industries historical stock prices, Yahoo Finance. This should help me get the link directly to Reliance. As you can see, reliance.ns. So this refers to Reliance Industries stock price as per NSE website. So this will open up the Reliance Yahoo Finance web page, which has Reliance Industries. There, if you see, there is a tab called historical data. I click on the historical data. That gives me the data, and Yahoo Finance also gives you an option to choose the date range in which you need to collect the data. It is said that for an effective computation of a beta value, especially when it comes to daily price movement of the kind of stock price movement, you need to have at least 60 observations from the past. Now, it can be 60 days in the past, it can be 60 weeks, or you can even collect 60 months data if it is available. I would generally take 60 months so that it covers almost last 5 years data, which is a fair enough period to judge. And you can also select the frequency as monthly and say apply. As you can see now, I have the historical data available for the period starting from 2012 April to 2017 April, which is today, on a monthly basis, so which effectively covers 60 months. So I will have 60 price range that is available. I will click on download data. That will open a CSV file, which is kind of an Excel file which is available. As you can note here, there are dates arranged here, and there are open price, high price, low price, and close price. We will have to be taking something called adjusted close price. Adjusted close price is a price which is adjusted for any stock split that had happened during this period, any dividend that has been declared, or any bonus shares given. So any change in the price due to these activities will bring down the price of the stock by a large margin in a given day. So to cover up that, what Yahoo Finance gives us is the adjusted close price. Adjusted close price adjusts the price for all such things. So what we may need is only this adjusted close price. So I would suggest delete all the other parts, and we will rename it as Reliance. Okay. Note that the date range I am still keeping. So now that we have the dependent variable data, we also need independent variable. Now independent variable is represented by the market index. Now the market index can be anything. There are different arguments. You can take a large market index like Nifty 50 or BSE Sensex, or there are also arguments like you can take a sectoral index. But again, it depends on the condition that you are working with, the kind of convincing, you should be convinced about what kind of index we want to take. For ease of calculation, let me take Nifty index. So if Nifty is my independent variable, for the same range of dates, I would need the stock price history of Nifty. So I will again go back to historical data, Yahoo Finance. There is a provision here to look up for the stock price. I will type Nifty, so it gives me the first option as Nifty 50. I click on it. And I get a similar historical data price. So again, I click on 5 years data. I'll say done. I need monthly data, and I will say apply. So now I have the historical price for Nifty 50 available for the last 5 years, segregated on a monthly basis. Now that I have it, I'll download the data. This will open another table, another CSV, another Excel file or spreadsheet, which has, for the same range of dates, this has the Nifty price. Okay, I'll rename this as Nifty for better understanding, and I will cut this and go back to my first Excel sheet that I have created, and I will insert the cut cells. So now I have the independent variable Nifty stock price, Reliance stock price, which is my dependent variable, and the dates. Okay, as you can see downwards, if you keep going downwards, you will be seeing that there are around 60 observations which are available. Also note that the dates that we are seeing here are arranged in a descending order. So we want it from 2012 to 2017 rather than 2017 to 2012. So how do we rearrange this? Select the entire data set, go to sort and filter, and say sort oldest to newest. So Excel is proficient enough to compute this, rearrange the data in this fashion. Now that you have done it, there are two other ways in computing the beta coefficient for this. Number one, we can compute the beta coefficient on the price itself. That means I treat this as the dependent variable and this price as the independent variable. Now that it is a time series data, I can compute it. There are also other arguments, like you can compute the return generated on a monthly basis and compute the beta of the returns. Most researchers in finance area have proven time and again that using the return as the Reliance return. I'll rename it as Reliance return. How do you compute the Reliance return? One of the return parameter is called return relative. Return relative is today's price, which is divided by the previous day's price or previous month's price in this case. So I compute this and I double click on it, and I have the return relative for all the dates. Similarly, I can also calculate Nifty's return relative. In the same fashion I'll calculate. So another easier way to do is just copy this and paste here, so that this is also computed. Now instead of directly taking the values of Nifty and Reliance, I can use the return relatives, so that you have a smoother flow of the data, which enables for a better predictor variable, predictor coefficient. Alright, so the beta can be computed in two ways. First, let me show you the easier way. If you quickly want to know what is the beta coefficient between these two, there is a function called slope. There is a function called slope in Excel. By the way, I'm assuming that you are comfortable with Excel while you're working on it. I'm not explaining what is a function. Okay, I'm directly giving you that slope is a function which is available, which requires two inputs. Okay, the first input, as it is being highlighted here, is the known y's. Remember, in regression, y's are the dependent variables. So in our case, the dependent variable is the Reliance return. So I will select those cells which have the Reliance returns. I put a comma. Now again go back. Now my second input that I need is known x's. X is the independent variable. In my example, it is the Nifty. So I select the array which has Nifty returns, and I close the bracket, enter. I get my beta coefficient value here. I'll just increase the font size so that you have a better view at it. So the beta between the Reliance return and the Nifty return is 0.879. Those who are doing serious research would also want to know whether this particular beta is statistically significant. In that case, one can use the data analysis package available in the Excel, MS Excel. Let me first see whether this data package is available. No. As you click on data, at the end you should have an icon which says data analysis. Currently it is not available, so I may have to install. Let me show you how to install that as well. I'll go to file, click on options, add-ins, and as you see here, there is an option called Analysis Tool Pack. Click on Go and select the Analysis Tool Pack and click on OK. This installs the package. Now as you see, the Data tab has this data analysis icon available here. So data analysis is meant for doing lot of statistical tests. You can do ANOVA test, you can do a correlation matrix, covariance, you can do exponential smoothing. Similarly, you also have the regression. Now our purpose is to firstly compute the beta coefficient. At the same time, we also want to check whether this model is working, at the same time whether it is statistically significant beta that we are talking about. So I select regression. Now again it is asking for the range. So my Y range, as I've already told you, is the Reliance return. I hold Ctrl Shift and press down arrow, so it selects the entire range. Now input X range, again I go back to the sheet, I select the Nifty return, I hold Ctrl Shift and down arrow, it selects the entire array. Now confidence level 95%, which is for a social science or a finance related paper, that would be sufficient. And where do I need the output range? Click on the output range. Let us say I need that output here in this column. So I press on OK. Excel gives you this output, which has various inputs than just giving a beta coefficient like what we have done. There are few things that we need to be focusing on here, which I will highlight with yellow shade, and I'll also explain to you. Okay. So what is a so firstly, what have we created? We created a model in this format. So where y is the independent variable, we are trying to create a model and say that the Reliance return depends on Nifty return, and there is an intercept here which is called alpha, and there is also a beta coefficient which actually is the sensitivity of y to the changes in x. This is what we are trying to measure. Now various inputs are given here in this output. Let us say multiple R is nothing but your correlation coefficient. So correlation coefficient talks about how these two variables are associated with each other. As we can see, the association is positive, so they both move up together. But also let me remind you, there is no cause and effect relationship between the two. Similarly, R square is the coefficient of determination. What it says is around 29% of the changes in Reliance return could be explained by changes in the Nifty return. It also means there is 70% more variation which is beyond Nifty return as an explanation. This is another variable. Higher this percentage is a better explanation of the relationship between the independent and the dependent variable. We also try to observe another factor called ANOVA significance F F value, which is way less than 0.05, which is our ideally assumed significance value. This says that this model what we are trying to build is a good model in terms of its fitness. That means the predictive ability of this model can be taken to be statistically significant. Similarly, the other highlight I highlighted here, the input, is the intercept, which is 0.1248. This is the A, the alpha here what we see, so that is 0.12. So in this case my predictor equation will be y equals 0.125 plus, as you can see, the beta value is 0.879, which is also the same result what we got previously using the slope function. Note that. So 0.125, so this will be my beta value into x. This is the model that we have created just now using the regression analysis. Another important variable, in this case, as you notice, the significance F value as well as the P value of the beta coefficient are both the same, which are less than 0.05. So what I presume by this is we have invariably been testing an hypothesis called there is no significant relation between dependent variable and independent variable. Opposite of this is the H1, which is there is a significant relation between dependent variable and independent variable. Now because this value is less than 0.05 and my alpha value, alpha as in the confidence level check is 95%, so allowable error limit is 0.05 or 5%, and this value is less than 0.05, I reject the H0. I reject the H0 and I fail to reject H1. Thereby I almost say that there is a statistically significant relation between dependent variable and independent variable. There is enough proof provided by this data set to say that any 1 unit of change in Nifty return, let us say Nifty return changes by 1%, the Reliance return will change by 0.87 into 1%, which is 0.87%. That is the relationship that we have established using the regression. Hope this session was useful for you. We will meet you again with more advanced techniques towards the same. Thank you.